Hello, everyone. We hope we are enjoying the show right now. But back on Earth with a great announcement today from Rémi from ExoS and Clément from Ascendance. So I give you the mic.
Thank you, Felix. So I'm going to start, and then we will jointly, with two voices, present this new partnership that we officialized today between our two companies. We are the two founders of the companies, and we are pleased today to announce the future of general aviation with respect to batteries. Let's start. I guess Ascendance booth is very, very close, so we did not spend time to present them, so no slides for Ascendance. But a few slides for ExoS, so it's less, we are smaller, we are newer to the game of aerospace industries. So I'd like just to present you, we are based in France, in Bordeaux, Southwest region. And we are battery specialists since now, it's been 8 years working on batteries, especially in the automotive field. So we are prototypists for automotive, for OEMs. And we developed several range of products, and we have internalized design simulations, prototyping and testing around batteries. And this is why we partner, thanks to this expertise. So we are not a startup anymore. We are a small SME, profitable since now 7 years, and selling worldwide engineering, test centers, or batteries. So this is all for ExoS. Now, set the floor for Clément for this announcement.
Okay, so Ascendance, just to give you a bit of an insight, if you want to know more, we are right across there, Hall 5 C270. So Ascendance is a startup created about 7 years ago with the objective to decarbonize aviation through hybridization. We've founded the company after working at Airbus on the EFAN program, which was the first electric aircraft to cross the channel back in 2015. And based on that experience, what we observed is that to decarbonize aviation, full electric, and electric is not sufficient enough. This drives really big batteries that are really too complex to produce, too complex to build and design and replace. And also it involves a very heavy charging infrastructure every time you take off and land everywhere. So what we've designed and what we think is that hybrid is a solution to have real-life applications, real-life products for aviation, to have a protected payload range that is viable for our clients, and also a proper scheduled operation with a limited impact on the infrastructure. So to explain a bit what hybrid is, if you look at a conventional aircraft, you will have your aircraft size for takeoff. The engine is sized there, and then you will have your engine run a bit lower with a higher fuel consumption, specific fuel consumption during cruise. And so this kind of is an unoptimized situation. So what hybridization brings is that you can downsize the electric engine, have it run at its maximum power all the time, have a better specific fuel consumption. There you will have your fuel gains, and you compensate that with an electric boost with a battery. Why this changes something is that designing a battery pack for a hybrid application is different from doing for full electric. It's much more power typed, higher currents, higher C rates, and this involves a specific way to design it.
Yeah, thanks, Clément. And we gathered the two companies around this common vision on aeronautics, hybridizations. And we take the forces of both companies. So Ascendance is basically an OEM developing aircraft, developing also propulsion system, hybrid propulsion system. So they have these facilities, they have this system view, OEM view that we don't have. And we at ExoS, we're looking at the battery for the bottom, from the cell. So we know how to weld, to laser weld, to sort cell, to have cell pairing, to cool them. So we have a top view, bottom view, and we think we are really complementary to develop a battery. So this drives us into an agreement where we split the jobs between our two companies. So in green, you've got Ascendance responsibility. In blue, you've got ExoS responsibility. So basically, ExoS It's very close to cell and thermal management, where Ascendance has this system view and directly connection with typically certification body. It's come from for Ascendance, and cell manufacture, cell welding comes from to XOS. So this is how we split it. And we split it that to develop our product.
So what we're developing is what we call a hybrid pack. So a hybrid pack is more than a battery. It's built around a battery specifically designed for hybrid applications, so with really high C-rate cells, a specific thermal management system that Rémi will explain a bit just after. But on top of that, to enable its introduction into actual aircraft and interact with OEMs, we need to go a bit beyond that. So what we do is we integrate the battery pack, but with, in the middle in green, a distribution system. So it's a high voltage power distribution core, so where we have protection, fuse, contactors, and so on. That's where it enables us to pull batteries together, modify which batteries is accessible to the propulsion and when during flights. And we do this dynamically during flight. And all of this is controlled and piloted by the orange box there, which is a hybrid energy management system to pilot energy in flight, to determine when do we use electric, when do we use thermal, to pilot the hybridized thermal engine, and really condition the batteries throughout flight to ensure that we have an availability of power throughout the flight. So that is the hybrid pack we're developing together, and the idea is to propose that to various kinds of applications, from the drone market, where we already hybridized a drone for the DGA, but up also to CS23 market, and also our aircraft at TIA that you can see on the stand if you want to come.
So Clément talked about thermal management. So here at XOS, we used to work in diesel engines 8 years ago. So we are mechanical engineer and thermodynamics engineer. And when we look at battery, we don't look at battery as electronician. We look at batteries as a thermal management system. So we started developing new way of cooling batteries. And we found out that talking with Ascendance, that this thermal management helps a lot for safety features that is required in aeronautics. And typically in the product that Clément presents, we will focus on a new kind of thermal management, which is called immersion. So we bath the batteries in oil. This is how main electronic system is already cooled today, even in aeronautics. Typically radars may be cooled by dielectric fluid like oil. And this is how typically the TGV is running today to cool the IGBTs, so the power electronics. So many electric system is used to work with immersion cooling. So what is immersion cooling? It's simply bathing components, live components, where you've got the electric currents inside in oil. Why oil? Because oil is dielectric, so there is no electric leaks around the part, and it allows us to directly cool live parts. We take sail, we submerge it in the electric field, we pack them to contain fire, and we monitor them with BMS. This is very, very simple, in fact. And this technology, sorry for the formatting, this technology allows many interesting features for the customers. First, we prevent fire propagation inside the battery pack by passive natural cooling thanks to the oil. We prevent water ingression into the battery pack. And typically today, one of the most frequent cause of battery fires, is water ingression. So we avoid it. We prevent explosions. There is no air, no oxygen, nothing in the pack except oil. So there is no possibility to build up a fire inside that may, in the end, explode. And we prevent arcing. Quite interesting feature in aeronautics, because even with very, very high, with very, very low pressure, we have no change in the electric properties of the fluid. So we can fly with batteries that are designed from the ground without any changes in the electric properties. Last but not least, aging is reduced thanks to better cooling. This allows us to have industrial use of batteries, not recreational, but very heavy loads, lots of cycles of batteries. And last, compactness. This is very linked to arcing. As there is no change in the electric properties, we can really optimize the battery size. And we demonstrated that on many, many I guess we can now have something like 70 automotive projects since the past 8 years, and we demonstrate all these features with various type of batteries on automotive project, and we are transferring this knowledge, leveraging this knowledge to go to aeronautics. And this helps us finding some initial customers. So we as startups like to talk with startups, so it was very easy for us to convince Flying Whales. No, it was not easy, but it was a great job. And we are supplying the battery for Flying Whales. You can see Flying Whales on the booth on hall 2. So the battery is very specific. This is an hybrid system. You've got, in fact, a big 1 megawatt turbo generator on board. You've got 2 megawatts of propeller installed, and in between you need to control the voltage of this grid, and this is done by a battery that is really heavily cycled. 500 kilowatts, only 10 kilowatt-hour of energy, so no interest in energy, but in power. And this is not enough. One customer is not enough. We've got an announcement. Sorry. This is yours?
Yeah, exactly. And yes, the idea for the hybrid pack is not to do a single design for a single client every time, otherwise we would have development costs that are way too high. So what we really don't want to do is have a hybrid pack that's designed for aviation as a whole. So it's for Flying Whales, but not only. At the Paris Air Show earlier in the week or yesterday, we announced a project that we have ongoing with Daher, based on the partnership that we had with them for a few years now, to work on the hybridization of their aircraft conjointly with Safran, Ratier on the propeller, and us on the hybrid pack section. Also, what's not on the slide, but we announced actually today, a partnership with Airbus on the same scope as well, to help them hybridize on the battery scope and push specifically hybrid packs for them and push the technology forward. So really, the focus here is to aim for fuel reductions everywhere, especially on the conventional applications. And on drones, it's different gains. It would be an increase in performance when we hybridize an electric drone, or more flexibility in operations, hybridizing a full thermal drone, where you can have a silent flight with being full electric. So it's really bringing flexibility. We have a proven track record of clients interested in the product, and we're really at the beginning of the road, but with a good track record already.
So you understand, only 2 public customers so far, but many ongoing, and that's all. Thank you for your attention, and we'll take your question with pleasure. Any question? We can circulate a mic.
Thank you for your presentation. I'm Claudio Bari from the University of Wolverhampton, UK. We have a problem with the C rating of the battery. Can you elaborate? In the automotive, you have 1 or 2 C, but with aerospace, you need at least 10, 20. So can you elaborate, please?
Yeah, thanks for the question. I take first and you complement. So yes, indeed. So automotive, you've got very, very large batteries that's typically on highways. It's not 1 or 2, it's 0.5 C. Yeah. But you've got fast charging. And so today, fast charging is typically 2 C in average. And the R&D project we are pursuing since 8 years is to raise these fast charging capabilities. So we demonstrated already an average 3.6 C without adding aging to the batteries, with the same cells, with this immersion cooling technology and specific charging algorithms. So this is first answer for automotive. But you're right, for aeronautics, it's even higher. So typically here, Clément has all the figure in mind. So it's typically 5 to even more C.
Exactly. That's why we say designing a battery pack for full electric and for hybrid are very, very different. If you look at even in aviation, a full electric pack, you will get around 2 to 5 C, but you have a very large battery to spread the power on. When you have a hybrid pack, in a kind of a CTOL, so conventional aircraft such as the one that we're talking about with Daher, the C rate is around 5, so it's higher but still closely. Anytime you have a VTOL application, which is the case for our aircraft, it's 20 C and above. And in that case, we already tested. Right now we have batteries good for flights that we discussed with the EASA that have been produced, that are being tested right now with those ratings, and those ratings have been tested. So yes, they are really high, but it draws a specific way to design the batteries. Bus bars are bigger, you have to arrange the cells differently, you have to handle thermal management a lot better, so yes, it's a different way of designing the pack.
So is this our graphite anode, or these are silicon anode?
Good question. Really precise question, but you're right. So typically, it's more or less graphite with some addition of silicon most of the time. But today with the cell we have, when you have silicon, you destroy lifetime. So it really depends. We need to find a trade-off for each applications today. And we have also application with even higher C rates. Here, if you calculate, is 50 C. So here, typically, the application is lithium titanate with graphite anode and lithium titanate, lithium titanate anode, not graphite, for even higher C rates.
Thank you very much. Thank you. Thank you.
Thank you for the question.
Any other question? Well, thank you so much.
Thank you.
Thank you.